Hello, my name is Nabil Afiafifi bin Amirul Nizam.
Hi, my name is Tia Xiuling.
Hi, my name is Li Yixuan.
Hi, I'm Linguations. We are from Group 1, Session 40. The title we choose is Zebra Crossing Control System.
At this stage, the green traffic light and red pedestrian light will on, the 7 segment will off, and the OLED display will show the stop icon. We need to press the button to switch to the next state. At this stage, the green traffic light will switch to yellow, the 7 segment will start to count down from 5 to 0, and the OLED display will show the wait icon. After 5 seconds, it will switch to state 3. In state 3, the red traffic light and green pedestrian light on, the 7 segment start to count down from 50 to 0, and the OLED display show the go icon. After 50 seconds, switch to state 1 again.
The function used for RGB LED is delay MS. It used for basic timing. RCC INIT enable clock for GPIO-B, TIM2, and DMA1. GPIO INIT is allowing the timer to control the pin instead of the CPU manually turning it on and off. The TIM2 function generates the precise signal needed to communicate with the LED, and the DMA function allows the system to send complex color data to the LED automatically in the background, leaving the CPU free to check button or update the display. For the WS2812 INIT, ensure the LED start in a no-off state so we don't get random flash of color when the system boots up. And for the WS2812 set pixel function, it takes our logical colors and rearrange them into correct bytes order in the data array so the LED interprets the color correctly.
There are 4 functions for the 7-segment display control. The 7-segment units function is to display a single digit on the units digit. The 7-segment tens function is to display a single digit on the tens digit. The 7-segment clear function is to turn off both digits of the 7-segment display. The countdown function is to run a timer that counts down from a starting number to 0 and updates the display every second.
For I2C1 start, it kicks off communication by sets up the start bit control register. It waits until the hardware confirms, then start the signal was sent, then it waits again until the display is executed. So in 12C1 right, it pushes 1 byte of the data onto the wire by waiting until the data register is empty, puts the bytes into the DR, and waits until the transfer is finished. And for this part of coding, we use one main function, which is I2C1 init. So this function sets up the physical pins and clocks on the chips. It's basically from the OLED command. It starts from I2C, sends 0 times 0, 0. This is the control bytes. The 0, 0 tells the display. The next byte I send is a command. And then also I send the command and then it stops. For the OLED data, same also with the OLED command. It starts the I2C, send the 0 times 40. The 40 tells the display. The next byte I send is a RAM data. And then it sends the pixel bytes and then it stops. So for OLED Kecil page, this tells the screen where the next byte of data should be drawn. And then for the OLED draw bitmap, this draws a full screen image. So it works exactly like OLED clear, looping through all the pages and column. Instead of sending, it reads a byte from the bitmap array and sends that. So the A1 in the bitmap becomes a lit pixels, a 0 becomes a dark pixel. So that where's the image being shown.